This is my lab report for the magnetic field of an electric bar. For the introduction, the purpose of this lab is to observe correlations between magnetic field and observable distance. It is also to further understand the Biot-Savart law and further explore this relationship computationally. For the overview of the results, I calculated the dipole moment to be 1.4 AM meter squared, and the magnetic field is proportional to R to the negative 1.4605 power. For the experiment setup, we used the magnetometer app on the smartphone to measure the magnetic field of a bar magnet, and we oriented the phone to be on the north-south axis of Earth to compensate for the magnetic north. We found the magnetic sensor on the cell phone, and we measured the off-axis magnetic field and calculated dperp using a meter stick. For the measurements to calculate K, using the Excel spreadsheet and measurements, we found that ln of K is equal to negative 12.785, and then we take e to the power on both sides, and we get K is equal to e to the negative 12.785, and then we calculate mu from the K value, and we get mu is equal to 1.4 AM squared. Now for the glow script code, we first define a function to calculate the dipole at various points, and then we calculate the different observation locations and display arrows based on each observation location on axis and as well as perpendicular. And then we finally calculate and print out the magnetic field at a 45-degree angle from the magnet. And then here in the corner is what was displayed as a result of the glow script code, and the small purple arrow is the 45-degree magnetic field at that vector. So for the results in error, the experimental result was fairly close to the computational. Experimentally, we got 2.09 times 10 to the negative 4, and then computationally we got 2.7 times 10 to the negative 4. So there are many potential sources of error which could result for this difference. There are inaccuracies in the magnetometer app and interference with the magnetic field due to other electronic devices or metal objects when taking the measurements that are out of control, and human imperfections or human error when taking the measurements. So for the discussion questions, in the experiment, you oriented the setup so as to compensate for magnetic north. What if you hadn't done that and instead laid out your meter stick at some intermediate angle with respect to Earth's magnetic field? How would the results have changed? So if this was the case, the magnetometer would be less accurate because the directions would be skewed in the magnetic north direction. And imagine if you had two identical magnets. What if you redid the experiment, but instead of using a single magnet, you used two identical magnets stuck together end to end? How would your measurements expect to differ? So the direction of the magnetic field generated would actually be the same, but the magnitude would be far greater and potentially doubled.